Hello everyone, my name is Betül. Welcome to my math class. On this video, we will talk about quadratic functions. So let's check them. Quadratic functions has three forms. One of them is standard form. On the standard form, we can see our function as ax squared plus bx plus c. When we take quadratic function, the degree on the function should be equal to 2. Therefore, a cannot be equal to 0. The second form is vertex form. Vertex represents our local max or local mean point on the graph. So, h and k value directly will be equal to coordinates on the vertex. Therefore, we call it represents our vertex form. A is common, so a cannot be equal to 0 on this form. The last form is intercept. We call this is intercept form because P and Q will be directly equal to x-intercept on the graph. So, A is common, it means A cannot be equal to 0. And when we see this form, we can directly say P and Q will be represent our x-intercepts. Let's check some examples. It says convert intercept form to standard form. So, first of all, according to given function, if we just distribute the parts in one by one, so we will get standard form. On standard form, let's remember, it was written in terms of y equals to ax squared plus bx plus c. So first of all, I will start with these two parentheses. When I distribute x's and minus 3, I will get x squared plus 2x minus 15. As the last step, I will also distribute 2. When we distribute 2 into the parentheses, our result will be equal to 2x squared plus 4x minus 30 will be equal to our function. On the second example, we can see it's a convert intercept form to vertex form. First of all, when we check the function, we can identify intercept one by one. Because on the intercept form, let's remember, y equals to 8 times x minus p times x minus q. P and q represent our intercept, which means 3 and minus 5 according to this one will represent our x-intercepts. On the quadratic function, the middle point of this intercept will be equal to our vertex. So, I'll add them, and in order to get their middle point, I'll divide it by 2. When I add and divide it by 2, we will get minus 1. Minus 1 represents x coordinate on the vertex. So if it represents x coordinate on the vertex, it means this point of the graph. So I'll put this x value on the original function in order to get the y. When I put minus 1 instead of x on the original function, our k, which means y coordinate on the vertex, will be equal to minus 32. So right now, we have the coordinate, we have the vertex, which means minus 1 and minus 32. Let's remember the vertex one. It was written in the form of y equals to 8 times x minus h squared plus k. Our h represents minus 1, I put minus 1, and our k represents minus 32. I put minus 32. Then, when we organize the inside of the parentheses, we will get y equals to 2 times x plus 1 squared minus 32 as our results. Next example say, convert vertex form to standard form. So, in standard form, we can see our equation in terms of y equals to ax squared plus bx plus c. So, I need to distribute this parenthesis firstly. X plus 1 square represents x squared plus 2x plus 1. Then I will distribute 2 into the parenthesis. We will get 2x squared plus 4x plus 2. But there is also minus 32 here. 2 minus 32, we will get minus 30 as our result. The next example, convert vertex from the intercept form. In the intercept form, we are talking about x-intercept. It means y value should be equal to 0. So after we identify our formula, after we identify the equation, we will put 0 instead of y in order to get intercepts. Then when we carry minus 32 to the other side, we will get 32 will be 2 times x plus 1 square. So we will divide both sides by 2. 16 will be equal to x plus 1 square. So we can identify 4 square and minus 4 square will be equal to 16. It means x plus 1 might be equal to 4 or minus 4. If it is equal to 4, x will be equal to 3, and if it is equal to minus 4, x will be minus 5. It means they represent our intercepts, 3 and minus 5. So in this situation, let's remember the intercept form y equals to a times x minus b times x minus q. A will be common on the vertex and intercept form. Because of this, we put 2 directly. Then we know one of the intercept will be equal to 3. So from x minus p, we can write x minus 3. And from x minus q, we can write x plus 5. So it represents our intercept form right now. Thank you for watching.